Good evening, all. I hope my voice is audible to everyone. Okay, Roshit sir, good
Got-
evening.
Yeah, good evening, Sushma.
Yeah, you can start the session, sir.
Yeah, thank you. Good evening, students. Give me 2 minutes. I'm setting up my whiteboard and those materials. Okay, good evening, everyone. Are you able to see my screen? Can I get a quick heads up in the chat box? If yes, yes, I'm getting an empty chat box. Okay, please send it to everyone. Okay, if you are putting something in the chat box, please send it to everyone so that I can see it in the same tab. So are you all there? Good evening. Good evening, Mambiya. Good evening, Saraswati. Good evening, Asmita. Good evening, Ranjita. Good evening, Shubham. Good evening, Lokesh. Good evening, Shivam. Good evening, Brajesh. Good evening, Navishimha. Good evening, Abjit. Okay, so let's start the session. Okay, so what we have done in the last session? What we have done in the last session? Anyone new to this session? Anyone new? Yes, array and array list. Okay, now Isha, you are new. Okay, Samsir. Okay. Okay, so on day one, we have discussed data structures, the types of data structures, and what is a data structure, what is the need of it. And then we discussed the time and space complexity, how to analyze the data structure using time and space complexity. Okay, time and space complexity we have discussed. So, and we have seen the logical programs. And on day two, we went with the patterns programming. Okay, so we discussed the loops and then we went with the patterns programming like printing stars, printing rhombus, and printing a pyramid, of pyramid, full pyramid, number wise pyramid. So these all things like butterfly pattern. So these all things we have discussed on the day two. And then day three, that is yesterday, we went with the closing of the butterfly pattern, and then we went with the array discussion. So we discussed what is an array, why it is useful, and how to insert into the array, or how sure like where the index starts in the array, like is it start from 0 to n minus 1, right? So we discussed that, and adding into the element, looping over your array, and what is the disadvantage of an array. Can you tell me what is the disadvantage of an array so that Sangam can understand? So he's asking me what is array. So let's ping him what is array. Okay, so fixed size, this is the disadvantage of your array. So array, once it is declared, how you will be declaring the array? The data type in Java, you'll be declaring with the data type array symbol, and then you'll be writing your array reference. And array is also an object in Java, so you'll be going with the new keyword and then new int. Like this, you'll be declaring. While you're declaring itself, you should give some size to it. Otherwise, it is error. Okay, so it should be of the fixed size while in declaration itself. If you wanted to increase like if the array size is not fulfilled, or if some space is missing also, then like that is waste only. Okay, so this is a syntax of your array, because array itself is also an object in Java. Okay, and then if you wanted to get the length of this array, you will be going with the array dot length. Good evening, Aryan. So array dot length, you'll be going with the array dot length. Okay. Then if you wanted to insert, you can insert using loop also. If you wanted to insert it individually, you can go with the index. You can go with the index 101. Array of 1 is equal to some 102. Like this, you can go on and insert. Okay, like this you can go on and insert. Yes, so first disadvantage is array index always starts from 0 to array dot length minus 1. Okay, array dot length minus 1. Okay, so the advantage disadvantage is fixed size. The next one is of same data type only I can keep it up, right? Same data type. Other than that particular data type, the other data types are not allowed. Okay. One thing is fixed size. Next one is same data type. Like if it is an integer array, you can only insert the integer. If it is a string array, you can only insert the string. Okay. So like this, you can insert, and then the next disadvantage is contiguous memory. It should be there. Contiguous allocation of memory. Okay. Contiguous allocation of your memory should be there in RAM. It should be like it should be side by side sequence pattern. Okay. So this is another the disadvantage. Any other disadvantages, guys? Inflexible structure. I didn't get you. Yeah, inflexible in the sense if the size, if you wanted to increase, it is not possible. Once it is declared, you cannot increase that size, right? So then for this reason, we went with what? We went with array list, right? We went with the array list. So what are the advantages of array list over array? It is dynamic size, right? Dynamic size, right? So if the element is inside, the object is inserted, we will call the array list is a class. Okay, so we will it is a collection class. So whatever we are adding into this array list, I will call that as object, not element. Okay, we are not adding primitive types here, we are adding object types here. So because of that reason, anything that is added into the array list is called as an object. Where here we are going with the primitive types. Okay, here we are going with the primitive types, but here we are going with the wrapper types. Instead of integer, I am putting integer. Okay, instead of int, I am going with the integer wrapper type. Okay, so because of that reason, every element that is inserted into the array list is called as your object. Okay, then how to insert into the array list? Using your methods, that is add method you can use, and you can insert into this array list. So how to create the array list? Basically, you'll be creating your class array list, and then al is equal to new array list. Okay, new array list. Then if you wanted to mention the generic, you can mention it within this angular brackets. What is generic, guys? What is generic? Yesterday I discussed. What is generic? So data type hierarchy, you don't know? Data type hierarchy. So many data types are there in Java. How many categories of data types are there in Java? You have your primitive, you have your non-primitive, right? Your non-primitive are nothing but reference types, right? Referenced types. Okay. In primitive, what were there? In primitive is nothing but given by the language itself. They were also called as your keywords, right? You have your byte, short, right? Byte, short, long, then float, then double, right? Then double, byte, short, long, float, double, and then char, and then boolean. Here comes integer as well. Byte, short, int, long. Byte, short, int, long, then float, double, char, boolean. These are the, like I'm explaining that only, what's your name? Anurag. I'm explaining that only. So byte, short, int, long are for your integers, right? Based on the sizes they were defined, based on the sizes and based on the ranges, right? So ranges, what is the byte range? Minus 128 to 128 only you can insert. Whereas short range is minus 32,768 to 32,767. Okay. Then long. Then integer is in some lakhs. You need not to worry about the range. Like long is nothing but some millions, we can take it up. Okay. So then float and double are for your floating types. Okay. Decimal types. Then char only one character you can insert. Okay. Then boolean true or false. Okay. True or false. So byte, short, long float, double, char, and boolean. Okay. So these are all your primitive data types. Double is also the float only. Float means after decimal you can insert 15 digits. Okay. If you wanted to insert more than 15 digits, you can go with the float. You can go with the double after decimal. Okay, this is the biggest size and as well as biggest range will come under primitive types. Okay, they will come under your primitive types. Then referencer types, in the sense these, like primitive in the sense they are defined by the language itself. From Java itself they will come. These are called as your keywords. So all should be written in the small letters itself. So when you're declaring, how you'll be declaring the variable, byte a is equal to something if you're giving. So this will come under the primitive type. So it should be in the small letter only. Okay. Whereas if you're going with the referential types, these are not defined by the language, these are defined by the user. Okay. These are defined by the user. Okay. These are not defined by the language, these are defined by the user. So here we will get strings. Your arrays also you can call that as non-referential or primitive type. Then classes, then classes, then you have your interfaces. You have your interfaces. Okay, strings, arrays, classes, this all comes under your enums. This all comes under your non-referential types. Okay, if you can see here, can I call this as your variable? Can I call this as your variable? Yes. Yes or no, Anurag? Yes. So I can call this as variable. So because it is storing the array, it is storing your something, right? So I can call that as variable, and that is of which type? That is of primitive type. Like that is of type is primitive, but the thing is you're storing the array type. So I can call this as a reference type. It is referring the inside that elements are of primitive type, but what it is holding array type. So it is called as your reference type. Okay, array is also an reference type. If you can see this array list also, if you can see this array list also, array list is a class. So this AL, can I call this as reference type now? Can I call this as non-primitive type now? Yes, right. So array list is a reference type. Array list is a class, so it comes under the reference type. So these are all coming under your non-primitive types. Okay, and then inside this array list also, you cannot insert primitive types. Okay, you cannot insert primitive types. Inside this array list, you cannot insert primitive type. Everything that you insert will be converted into again non-referential, non-primitive type only. If you are inserting integer also, it will take it as non-primitive. That is object type only. Okay, that is object type itself, because we cannot insert primitive values within the array list. Okay, they will remove in the future versions of Java. In the future versions of Java, they are also planning to remove these old primitives. All primitive types what we have discussed, byte, short, int, long, float, double. These all primitive types, they are also planning to remove it, because Java is object-oriented programming language. Java is object-oriented programming language. So object-oriented in the sense, what is meant by object-oriented programming language? The language should contain only object and classes. Object and classes. Because of this primitives, because of this only one thing, it is not becoming fully object-oriented. So because of that reason, they are planning to remove this also. So for that reason, what they have done, they, for this byte, short and long, for this replacement, what they have done, they came up with the wrapper classes. They came up with the wrapper classes for each and everything. For each and every byte class, for each and every primitive type, they came up with the wrapper class, separate predefined wrapper class. Byte, short, in long, integer. Okay, integer. Then you have your long, like this. They came up with the wrapper classes. These are classes. Okay, so only I'm putting it in capital letter, first letters. Okay, byte, long, float, like this. For every primitive type, they came up with the wrapper class. Okay, and these types only I can insert within your collection class. Okay, this type only I can insert within your collection class. For suppose if you go to the yesterday's session, what we got some error while we are reiterating over this array list. We got some error like the int cannot be converted to object. Like that you got the error. Integer cannot be converted to object. Like that you got the error. Or like int cannot be converted to object, because what I have done in the for each loop, I kept int here, int a, like this I have given, right or not? Yesterday in yesterday's session, I given like this while looping, right? Yes or no? Yes. So that time what you have got this in this array list, you are adding objects. So what error you have got? Object cannot be converted to int, right? Object cannot be converted to int. Like that you have got. If you are inserting integer also, it will take it as big integer only. Like this only, wrapper type only it will take. If you are inserting long also, float also, it will take it as wrapper type only, which is nothing but object type only. So you cannot insert primitives inside your array list. Are we clear with the primitive and reference types, everyone? Okay. So if you wanted to insert into this array list, what you'll be using, you'll use a add method. Add method you'll be using, and you can insert it within your array list. And if you're writing some primitive, some generic here, only that type only you can insert. Okay. So the advantage of array list is, first one is dynamic. Second one is you can put heterogeneous type elements as well. Heterogeneous in the sense different types also, different types also you can use. Okay. And within the same array list, you can add different data type elements. And then what is other disadvantage? It is okay. These are the two disadvantages we have, right? So dynamic as well as heterogeneous type. And you have the methods for our inserting. Okay. You have the methods for inserting. If you wanted to find the size, you can go with the size. You can also iterate over using iterator method. Iterator method. Okay. So let me see yesterday's code once. Let me show you yesterday's code once so that you'll understand. See here, if you can see here, uh, can I call this string as your reference type also? Yes, string is also a reference type. Here, if you can see in array list, I've created the array list, and here I'm adding multiple data type elements. I'm adding multiple data types elements, 12, 13, Roshi, 34.9, XLR, like that, multiple data type elements I'm adding. Okay. And then what I'm doing, like see, here I'm putting a F here. Means I'm adding it as a primitive type, but internally it will automatically convert this primitive type, which is nothing but float I'm inserting. This float automatically it will convert it into float class. Okay. It will automatically convert it into float class. Okay. So that object type it will automatically convert. Okay. So if you're inserting as a primitive type also, it will take it as a wrapper type itself. Okay. Wrapper type, which is an object type itself. Okay. So array list is a heterogeneous type, but you can also make it homogeneous using your generic. Generic in the sense, in the angular brackets, you'll be mentioning your type. Okay. Suppose if you wanted to insert only integer values. Suppose if you wanted to insert only integer values, like here also you should write, basically generally you should write here also integer only. Like that you should mention your generic on the left side also same, right side also same, but you can ignore this. You can ignore this from Java 8, you can from Java 7. You can ignore this and you can write just this shortcut. Okay. And if you can see now, I made this as homogeneous type now. Because of generic, it will become the homogeneous type. And we can see on the 15th line, on the 17th line, on the 16th line, you're getting an errors. Are you understanding, Sandhya? You're getting an error. Because of the generic, I was not able to do that. Okay. And Diksha, like see, you're adding primitive type here. I'm adding primitive here. 34.9F, we'll add it in primitive only, right? Like this only, right? So like this float B is equal to 34.9F. Okay, so this is nothing but primitive type. This is nothing but primitive type. Now you see, I will add this primitive type here. I will add this primitive type here, and I will convert this generic type to primitive type. Okay, now you see all are errors, but here you will not get an error. See why what it is telling, create local variable. Local variable is created, right? B, right? B. See, you are not getting error here. Means what that means? You are adding float primitive type, but it will automatically internally it will do the concept of auto boxing. Okay, it will automatically do the concept of auto boxing. If you can know auto boxing in core Java, auto boxing says you convert primitive type into float type. It will wrap your primitive type to integer type. Okay, this is nothing but auto boxing. It will do automatically. Automatic conversion it will do from primitive type to wrapper type. Okay, y means within an array list within your collection class. This is a collection class. So within a collection class, I can only add the primitives. I can only add the object types. Sorry, I can only add the wrapper types or object types. Are we clear, Diksha? So within the collection class, you will use the wrapper types mostly. Within the collection class, you need to definitely use the wrapper class. Okay, so this is how, like if you wanted to iterate, what you'll be doing, you can use your normal for loop, your collection. You can use a normal for loop, or else you can go with the for each loop as well. This is nothing but your for each loop. Right here you see, since I'm inserting multiple things, if I'm not writing generic, I will insert multiple things, right? I will insert multiple things. So because of that reason, I will write directly the object type, because object type is a parent type for all your wrapper types, right? So because of that reason, I'm writing the object type here. Okay, like this I'm printing. You can also go with the iterator and you can print it. al.iterator, that method you can call with the reference, and then that will give the iterator and you can print it that way also using the while loop. Okay, so this is how we discussed yesterday. Mhm. So if you wanted to get it by index, you can use a get method. Okay, you can use a get method. Okay, so this is what we have discussed in the yesterday's session, and we went with the other problem, right? That is move zeros to end of the array. So what we have done in this question, what is the logic we have done in this question? I have given one assignment also, right, to complete this solution in the one swap itself, right? Are you guys done with this? Are you guys done with this? Yes. So what is the intuition behind this we have done? So basically we need to move all the zeros to end, right? All the zeros to end of the array. So for that reason, what we have done, we are counting the non-zero elements, right? We are using a counter initialized to zero. We are counting the non-zero elements for that. Okay, because we need three places in the front. We need three, there are three non-zero elements are there. There are three non-zero elements are there. We need three places in the front for those non-zero elements. So for that reason, we are only counting the non-zero elements. So what we are doing here, we are traversing over the first the initially the count is 0, and then we are traversing over the array until length, and then if array of I is not equal to 0, you are what you are doing, initially the array is like this, right? 0 1 0 3 12. So you are moving this array element to array of 0. Array of 0 is equal to array of I. And then what you are doing, you are incrementing the counter pointer. Now counter will become 1. Okay, and then again you are iterating over the loop. Again you are iterating over the loop. So now what will happen, 1 1 will come. Okay, now you are iterating over here. So it is also a non-zero element. It is also a non-zero element. uh, it is also a non-zero element. So what will happen, array of c is equal to array of I. Okay, array of c is equal to array of I. So it will be again the same, and then it will go iterate here. Okay, it will go again iterate here, and it is 0. So it will not go inside the if condition, and then it will move here. It will move here to this 3. Then what will happen? 3 is also not equal to 0. So now what will happen? Like it is 1, right? The C is 1. So now what will happen? Like it will be 1. Like it will come to the first position, 3, 12. Okay, you did not got the logic, huh? Okay, let me explain it once again. Ding, 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 ding. Okay, don't worry, I will explain it once again. Mhm. Okay, I'm moving into my whiteboard itself. Okay, so what is the input that is given? 0, 1, 0, 3, 12, right? So what I am doing, what is the problem is I need to move all the non-zero elements to the front. All the non-zero elements should be in the front. Should be the output. In the same position they were. In the same position they were. The order should not be damaged again. The order should be same, and I should move the zeros to the end. Are you clear with the problem statement? Yes, all the new people who have joined. Yes. So this should be the output for me. Okay, this should be the output for me. So what I am doing here, since the order should be same, anyways, there are three elements over there. Means I need to move all these three elements to the front. Means I require three positions. I require three positions in the front. And then I will insert the zeros at the end. How many positions are left? That many zeros I will insert. Okay, like that I'm thinking. Okay, to count to the non-zero elements means I'm thinking like to count to the non-zero elements. How many non-zero elements are there other than zero? What elements are there? I will count it up. I'll push to the front, and then at the last the spaces will be empty, right? So if they are coming to the front, the spaces will be empty, right? The spaces will be with some number or something. Okay, for with those like whatever the spaces remain means there are like five elements are there. In the five elements in the 5A, how many were non-zero elements? Three. If you are moving to the front, then how much array will be left? Like two spaces will be there to make it as zeros, right? Like that I'm thinking. Okay, so now what I will do, I will take one pointer, that is C pointer. I will initialize it to 0. I will initialize it to 0. Are we clear until this point? Yes. So now what I will be doing, I will run a loop. So now I is equal to, I will be staying at the 0th position. Okay, and now it is a non-zero element only, so I need not to count or I need not to push it somewhere. Okay, so now what I'll be doing, I'll move to the next one. I will immediately move to the next one. So now I will become 1. I will become 1, and then C is initially C is 0 itself. Okay, C is 0 itself. So now it is a non-zero element. So first what you need to do, you need to move this element to the front. Okay, at the C pointer. Okay, so what I will be doing, I will move this element to the front at the count position. Okay, at the count position, I will move this element. So now what will happen? So, Suyash, the notes is already shared in your LMS. You can check. Okay, here you have your one. You have your one. Okay, here also one. I will move this element. That's it. I will move this element to the front. That means 0 is overridden with 1. Okay, 1, 1, 0, 3, 12. Are we clear until this point? Now I will increment the pointer. Now I will increment the pointer to now I will increment the pointer to 1. Okay. Then I will increment the point. I will also increment your I value, that is it will go to the 2 pointer. Okay, it will go to the next step. Okay. Now it is 0. So I need not to worry. I will move to the next again. Okay, this will be now 3. Okay, now it is a non-zero element. So what I need to do? I need to move it at the counter pointer. So at the first position basically. Okay, so I will move this element to here. I will move this element to here. So now what will happen? 1, 3, 0, 3, 12. Okay, then what I will be doing? I will increment the counter value. I will increment the counter value. Okay, I will increment the counter value to 2. Okay, I will increment the counter value to 2. Now I will become, I is pointing at 3, right? I will become 4. I will become 4. Okay, so now the pointer will be at here. Okay, now what I need to do, it is again a non-zero element. So what it should be having? It should go at the second position, at the count position, that is second. So now what will happen? 1, 3, 12. Okay, then 3, 12. Did we get the expected array? Did we get the expected array? Yes or no? Did we get the expected array? No, right? Because here it is 0, 0, but here it is 3, 12. So now what I will do, I will take another loop to make it as 0. Okay, I will take another loop, or else I will run the loop from this position. Anyways, I am until here. Until this point, C is updated. Okay, C is updated. Means after this, I need to make zeros, right? So I will run a loop from 2 to n minus 1. Okay, 2 to n minus 1. Okay, length minus error dot length minus 1. I will make this as zeros. So this is your output. Are you clear? Are you clear? Yes. So like this, I will do this. So I'm doing the same here. If you can see, okay, if you can see this solution, if you can see the solution here, I'm doing the same. What I'm doing, int c is equal to 0. I'm running the loop. I'm running the loop from I to array dot length, and then if it is 0, what I need to do, I need to put that element at that count position. Okay, otherwise I will increment that. Okay, then what I am doing, I am putting the remaining elements as 0 itself in the second pass. But what I am doing, what is the problem with this solution is uh, the another problem I can tell you what is the other problem is. See, at first position, I will again increment, I will again swap it. Okay, so there should be one condition here, that if array of I not equal to array of C, then only you go ahead and swap. Okay, then only you go ahead and swap. If it is same, don't swap it. Don't swap it. So why is this condition I'm writing means, suppose, see what is happening here in the second iteration here, if you observe, here it is 1, here it is 1, and the counter is updated to 1 itself, right? And the counter is updated to 1 itself. And when the pointer comes here, it is also a non-zero element. So now what will happen? The same, again one swap, again the same thing will happen, right? Again, it is copied and put it at the same position. That is happening. So because of that reason, I'm checking this condition. You got it, right? Because of that reason, in the second iteration, what will happen? C is equal to 1, it will become, because 1 will be coming to the front, right? And I is also will become 1. But what will happen? The array will be like this, right? 0, 3, 12. 0, 3, 12. But I'm comparing these both elements. I'm comparing the again what will happen when I is equal to 1, it is a non-zero element. So when you are not writing this condition, what will happen? It will come inside array of 1. Array of 1 is equal to array of I, array of 1 itself. It will copy the same and it will increment. It will copy the same and then it will increment. So like that it is happening. So instead of that, what I am doing, I am just checking this condition. If it is, I'm just checking that condition, that if it is not equal to only, you swap it. Okay. Not equal to only, you swap it. Like that, I'm checking the condition. Okay. Okay, fine. But here what I am doing, if you can see here, I am using the another loop here. Another pass I am passing. Though I'm iterating over the array for two, only one pass only I'm doing, but using only two loops. I can do it in the one loop, right? In one pass only I can complete this by swapping, right? By swapping, I can complete it in one pass itself, right? So instead of like this, what I will do, instead of like this, what I will do, I will just swap the elements wherever the non-zero element is there. What I am doing in this case, I found the non-zero element here. So what I will do, I will just swap this 1 here and 0 here. Is that possible? I will just swap this 1 here and 0 here. Okay. And then 3 here. Then what I am doing, then 3 here, then 3 years 0 year, like that I will solve. So what I am doing is now in this case, in one pass only, what I will do, 0 1 0 3 12 is there, right? When the non-zero element is found, what I will do, I will swap with the zeroth element. Okay, 1 0. So now what will happen? 0 will come here, 1 will come here. So 0 3 12. Okay. And then what I am doing, I'm iterating over it. Okay. So next one, 0. It is always, anyways, it is 0. And then 3. Okay. And then 3. 3. I'm swapping with the first one, right? So what will be happening? So 3 year, 0 year, then 0 year, then 12. Instead of overriding, I'm just doing swapping with zeros. Okay. Now again, what will happen? It will go to the next and it will go to the next, right? So 12. 12 is again swapped with 0. 12, 0, 0. This solution is fine, right? This solution is fine, right? In one pass itself, I can do it. One traversal itself, I can do all the solution, right? So let me remove that second loop for filling the zeros. Let me remove. Before that, I will copy this solution so that you can, we'll copy this solution into the notes. Okay. Okay, if you can see, I will remove this loop from here. Okay, if I will remove this loop from here. Okay, so if array of I not equal to 0, what I am doing, if array of I not equal to 0, what I am doing, I am doing a swap. Okay, I am doing a swap into this one. Okay, so how to do the swap? So I will take one temporary variable to accommodate that array of I. Okay, accommodate that array of C value, and then array of C is equal to array of I, and then array of I is equal to temp. Array of I is equal to temp. Okay, like this I will swap it up. Okay, I will swap it up like that. Okay, so now what will happen? If directly the swapping will happen, and then I am returning that array. Okay, in one pass itself I can do this. Okay, now if I run the solution, if I run the solution, array of C, why is it giving error? Okay, semicolon. Drew, I am not getting you what you are telling. Can you take some input? I will do that. Can you give me some example input so that I will do that? Okay. If and then for loop, okay, correct, and then C and then 0. Okay, accepted. And then clicking on submit. Let me check whether the test cases are passing. Passing. Okay, all the test cases passed. Okay, so this is the thing, but a big O of one only you can do this solution. You need to traverse the array. You need to see all the elements, right? Definitely the solution time complexity will be big O of n itself. Okay, you cannot do it in constant time. Okay, and the space complexity is big O of constant itself. Okay, you got this solution, right, everyone? I'm just swapping it. Whenever there is a non-zero element is there, I'm counting it, right? So based on that, I'm swapping it. Okay. Is it clear for everyone? Can I move to the next problem? Yes. So next problem, duplicates in an array. So finding all duplicates in an array. Next easy problem. Okay, medium problem. So what you need to do here, given an integer, given an integer, array names of length n, names of length n, where all integers or names are in the range 1 to n and each number appears at most twice. Okay, the array size also they have said, see, array size n and all the elements will be inside that from 1 to n itself. Means the array size is how much? See, 1, 2, 3, 4, 5, 6, 7, 8. So means inside that elements also will be from 1 to 8 only is telling. Will be in the range from 1 to 8 only is telling, and each integer appears at most twice. Okay, at most twice is telling, at most twice. More than twice also it can appear, but at most twice it will appear. And return an array of integers that appears twice. Okay, so at most twice. Each integer will apply more than once. So you need to return those as result. So here you see, we have here 4, 3, 2, 7, 8, 2, 3, 1. In this 3 is repeating, 2 is repeating. Okay, so because of that reason, the output is 2, 3. Whereas here 1 and 1. So the output is 1. And here 1 only. So nothing. The output should be empty. Okay. And the constants, if you see, the same constants what we have discussed until now, that is there. Okay. Size can be 10 power 5 until 10 power 5, and numbers range is from 1 to n, and each element in names appears only once or twice. Okay. So can you try out this solution? Can you try out this solution? I will remove this solution from here. Can you try out this solution? You can directly do it in the lead code and let me know what is your intuition first. Okay, once you have tried or once you have seen this problem, what is your intuition? Like in the pseudocode format, you can in English or in some coding English words. Also, you can describe how you can do your solution in the chat box.
It's 8 o'clock.
Okay, so I'm seeing some responses in the chat. We can traverse array and maintain the hash map so that whichever number is repeating gets added in the table. Mm, right, right, correct. You can maintain a hash map and you can keep it up. Sort elements, we can check same or not correct. First, I will consider the element at index 0 and compare with remaining elements. Matches, it will print it, or leaves, continue the process for all indexes. Sirisha, you can go to the channel. I will show you the end also. You can go to the XLR channel. In that page, if you go to the video section, you can get that. Or in the live section, you can get that. I will show it in the end. Okay. Ranveer solution. Okay. So, yeah. Yeah, you must write an algorithm. Yeah, not read this. You must write an algorithm that runs in big of n time and uses only constant auxiliary space, excluding the space needed to store the element. Means you should not use any array or an hash map. Extra array you should not use. You should do it in the in place sorting. In the same you should use only result array or input array, but other than that extra space you should not use. Okay, so it cannot be done with the hash map. Correct. So what I'll be doing, I will go at 432782231. Okay, let me remove this drawing or else let's leave it. Okay, what is the solution? 432 to this, I'm closing it up. 432782231. 432782231. Right. Okay, in this the output should be like you should find only the duplicates, so it should be 2 and 3. Okay, so this should be the result here. So first solution that comes to my mind is brute force solution. Seeing this, so brute force solution, what I will be doing, a general solution as who said as Manjunath said. Yeah. So what I'll be doing, I will compare each and every element. I'll compare each and every element. I will start from zero index, and then I will compare whether this is there in the rest of the array. Whether it is there in the rest of array. I will use a one loop for indexing out each for traversing, and I will use another loop for checking in the rest of the array. Okay, for checking in the rest of the array, two loops I'll be using, right? So 4, is it present? No. So I will move to the next one. 3, is it present? Yes. So what I'll be doing, I will take the result array and I will check whether this is already added. Otherwise, it will become a duplicate again. So I will check whether 3 is already added in the result array or not. It is not there. So I will add it up. And then 2. I will go to the next iteration. Then again, I will check in the rest of the array. I will check in the rest of the array. So like this, I will go ahead and do. Okay. Yes, I will go ahead and do in the rest of the array. So for this complexity, I will be using two loops. One to iterate from I is equal to 1, I is equal to 0 to n. Okay, next one is to iterate in the rest of the array. Again, I is equal to I is equal to your I j is equal to I plus 1 to n. Okay. So again to iterate over it in the rest of the array. Before adding, I will check it in the result. I will check it in the result whether that particular duplicate element, if it is found, if array of I double equal to array of j, if it is duplicate, then what I will be doing, I will also check in the result array if it is already added. Okay, if array of I is added or not, I will check it up. Means basically if it is added, where it will be at the end only, right? It will be at the end only, right? So it will be at here only, the other element, right? I will check the previous element. That is enough for me, because anyways I'm adding it in order, right? So I will check just the previous element if it is there or not. If it is not there, I will add it up. So that is a brute force solution. So for this, the time complexity will be big of n square. Big of n square. Efficient? Efficient or not efficient? Not efficient, right? So then, can I do it in big of n? Can I do it in big of n? Let me check. Or big of 2n, or can I do it in one pass without a nested loop? Can I do it? So for this reason, what I'll be doing, this solution you understood, right? Just a basic solution. Okay. Next one, what I am doing for optimizing it, what I can do is I will iterate over it, and then what I will be doing, since anyways the numbers will be there from 1 to 8. So basically there will be 8 elements will be there, right? 8 elements will be there. 1 to n. They are only given in the question that 1 to n will be there. The size of the array it will match. So anyways the 8 elements will all be there. So what I will be doing, I will take another array. Okay. I will take some frequency array. I will take one frequency array. But this is another solution I am thinking of. So I will take one frequency array. So in this array, I will take this size as also 8. So 1, 2, 3, 4, 5, 6, 7, 8. Okay. Whenever I found the element here, see 4, 4 at the fourth position, what I'll be doing, 0, 1, 2, 3 at the fourth position. What I'll be doing, I will put it as 1. When I have visited it, I will put it as 1. Okay. And then 3. And 3, what I am doing, I visited it. So 1, 0, 1, 2. For this position, I'll put it as 1. And here also for 2, 0, 1, I'll put it as 1. Means the term minus 1, array of y minus 1. Okay. I'm using how? Frequency of, this is something frequency array I'm taking. Okay. Frequency of array of I minus 1. Okay. Frequency of array of I minus 1. And then 7 at this position I'm putting it as 1, and 8. Okay, both these positions I'm putting it as 1. Okay, and then 2. Now you see 0, 0, 1, 2, 3, 4, 5, 6, 7. At this position, see, when you're getting the 2 here, see, it will become 2 now. Okay, this will not become 2. This will become 2, right? This will become 2 now. This will become 2 now. And then for 3 also, this will become 2. Okay. So now what is happening? This is becoming 2. This is becoming 2. Then this is becoming 1, 1. And then 3. 3 also it is becoming 1. And then 1. It is becoming 1. Okay. 4. 5 is not there. 5 is not there. Okay. 5 is not there. And then 6 is also not there, right? 6 is also not there. So theirs are empty. But if you can see, so these become as 2, means basically these are duplicate elements. So 1 plus 1, what is a duplicate element? 1 plus 1, which is nothing but 2, 2 plus 1, which is nothing but 3. You got the solution? You got the solution? Yes. Can I get a heads up in the chat box? Bhagat Chand, I explained the same solution. Can we do this taking an array and counter variable using a loop? Using a loop and go through each element and add only unique element. That is only I did, right? Using a loop. As soon as we get a duplicate, the counter gets an increment. The counter gets an increment. Then how you will find the element? Okay, you will initialize the counter every time. Every time you enter the loop, you will initialize the counter. That's fine. Okay, so this is how is space efficient when we are using another array. Yes. So for this, what I am doing for this, the space complexity is big of n, but we should do it in big of one itself. No one is telling when I'm explaining the solution. No one. I'm expecting the answer in the chat box. I was just testing whether you are attentive or not. So when I am explaining the solution, no one is telling no, sir, it can't be done. So I was going through the. I was doing that. Okay. So this is not an efficient solution because the problem should be done in big of n. Big of n. Big of constant space. Constant space it should take. It should not. We should not use the other array. Okay. So for that reason, these two solutions are done. Let me. This can be done in big of one time complexity only. Okay, big of n time complexity only. Here we don't need two loops. Okay, we'll do it in the one loop itself. Okay, because we are only traversing only once. We are traversing only once. We are marking which are visited. That's it. And then we will use another loop to loop over the, but we'll not use nested loops. We'll not use nested loops. We'll use two passes. We'll use two passes. Okay. So let me clear all this. So this is also not efficient because we are using the other array, right? So for that reason, what I will be doing, I'll move to the next solution. What I can do. Okay, I got it with the other one. So what I will do, mm, I will go with the negative solution, making it as negative here itself. Okay, making it as negative here itself. Making that particular index as negative. Since the array is starting, this is the int given. The array elements will be from 1 to n only, and it will also have a size of n itself, right? Size of the particular size only, right? Since this range is given to me, so what I will be doing, since this range is given, this constant is given, that the range of the array will be only from 1 to n. So because of that reason, what I will do, I have got one int here. When I visit this element, when I iterate over this element, what I will do, I will 4 is there, right? So 4 in the sense in the array format, what will be its index? What will be its index? It will be 4 minus 1, which is nothing but 3, right? So 0, 1, 2, 3. I will make this element as minus 7. Okay, I'll make this element as minus 7. Okay, now I will go here, next iteration, I will go here, 3 in the sense 3 minus 1, which is nothing but 2, right? Which is nothing but 2. So now what will happen? It will become minus 2. This is already become minus 7. Okay. So minus 2. I will place this element as minus 2. I will overwrite this element as minus 7. Okay. And then what I will do, I will move to the next iteration. Next, 2. 2 minus 1. 2 minus 1, which is nothing but 1. I will go to that 1 index and I will make this element as minus 3. Minus 3. Okay. And then 7. And then 7. 7 in the sense, 7 in the sense 6, right? 6. So 0, 1, 2, 3, 4, 5, 6. I'll make this element as minus 3. Okay, minus 3. Then 8. Then 8. 8 in the sense 7, right? 0, 1, 2, 3, 4, 5, 6, 7. I'll make this element as minus 1 because this particular index is visited, I'm telling, to that particular element. Okay. Then 2. 2 minus 1, which is nothing but 1. So see, if you can see now, 2. When you're visiting 2, you'll again visit the first index itself. You'll again visit the first index itself, but this is already minus. So means minus in the sense it is already visited by some other element. Means you have already visited it, you are coming to the same vacation again. You have already visited that place, but you forget and you are saying as I have not visited it and you came to the same place. Then when you come to that place, suppose you have visited some Vizag or some Vizag you have visited, some when you are in the childhood, and now you are going with the friends again. You are going with the friends again, and you said to your friends that you have not visited it. But when you go to that place, you are remembering all the places what you have visited. So like that, I'm tracking. I'm tracking using the negative. So see, this is already visited by this 2. So because of that reason, it is negative. So now what will happen? I got the answer. I will add this particular 2 element to the array. Okay. And then I will move to the next element 3. 3. 3 in the sense 0, 1, 2. This is already negative. Means it is already visited. So I will add the 3 also to the array list. And then 1. 1 in the sense 0th element, right? I will make this as minus 4. This is not visited, so I'm making it as minus 4. You got the answer now? You got the answer now? Yes, no? Yes. So this, what is the time complexity it will take now? What is the time complexity it will take now? Time complexity of this. I'm doing it in only one pass and I will do it in only one loop only. So I will not use nested loops. The time complexity will be big of n. Space complexity will be constant itself, right? Because I'm not using any extra array other than the result and input array, right? So let's code this solution fast. Let's code this solution fast. Okay. So I need a loop for int I is equal to 0, I less than length dot length I plus plus. Okay. Then what I need to do first, I need to find out the index of that particular element, right? Of that particular element, I need to find that index. So int index is equal to array of I, array of I minus 1, right? Array of I minus 1. So if it is 4, I will go to the third position, right? I will go to the third position, 0, 1, 2, 3. So the index will be minus 1. But if it is positive, then you need to, what will happen? If it is already negative, so if it is minus 3 is there, if it is already negative by another element, if suppose minus 7 is there, it is already negative by some other element, right? So you cannot move minus 7 minus 1 will become minus 8. Okay, so that will become a wrong again. So I need to make it as positive. I need to make it as positive. You can use this function math dot absolute, that will make it as positive. Otherwise, you can also make it manually. I can also make it manually if it is positive. Otherwise, you can do with this function from your library, that is math dot absolute. Okay, and then what I am doing, I need to make that particular element as negative, right? Before that, what I will do, I will check whether it is already negative. Okay, whether at that particular index element, if it is already negative, I will check, right? What I will be doing, I will make that element as I will check whether that particular, but at that particular index, I got the index now. In that index, whether it is already this 7 is already negative or not, I need to check. If it is negative, I will directly add it up in the result set. Okay, in the result array. So for that reason, I will take one result array. So the result array should be returning. What it should return? It should return a list, array list it should return. So for that reason, what I need to do, I need to declare an array list. Array list, array list of integer, array list of integer al is equal to res is equal to new array list. Okay. Then what I need to do, I need to if array of, so where is my loop where I have written. Okay, if array of index, if array of index, if array of index less than 0. Okay, if array of index less than 0, what you need to do? You need to add, right? Res dot add, res dot add of your array element, right? Array of I, array of index, array of I. Okay, array of I you should be adding. Okay, then what you need to do? Else, what you should be doing? Else, you should make that element as false. And you should make that element as negative, right? That particular index element as negative. So array of index is equal to minus of array of index. Should make that element as negative. Okay, fine. If array of index less than 0, what you need to do? You are telling you are adding it to the array list. Then you can return that array list here or return res. Okay, fine. Is the solution correct? Are there any issues in the solution? So if it is already negative by another element also, what you can do, you can make it as positive. Okay. So let me run this. Let me run this. What it is telling, math dot absolute array of I. It is not array of I here. It is names. Okay. Okay, making it as array. Okay. Math dot absolute of array of I. That's fine. Okay. Accepted. And then when I click on submit, accept. Okay. So are we clear with the solution? Are we clear with the solution? Yes. Let me copy this and put it in your notes. Okay. Next one. Next one, what I will do, maximum subarray. Yeah, so I was explaining you the brute force approach and then the other approach, and then I'm optimizing it, right? So everyone should understand also, because I'm switching between multiple solutions, and everyone should understand why this is better than that. So it is taking bit time, okay? Because some will be understanding very quick. Some will not be able to, maybe they will be seeing somewhere, or they will not be able to understand that much quickly. So I'm explaining them why that is. So it is taking bit of time. If you don't want, I can directly explain the optimal solution step away. Yes. So yeah, that's the problem, Dhruv. So if I explain it directly, if I explain it directly with mouth, like this, like we can do, then in the beginning only they were telling not understood, sir. Can you explain again? So that is the question that is coming. So what I am telling, that I am representing, so that everyone will be in the same pace. Okay. So okay, next one. Next one. So maximum subarray. Okay. If you can see this, given an integer names, find the subarray of the largest sum and return is sum. Okay. Return is sum. I will go a bit faster only, Dhruv. Not to worry. Okay. Not to worry so much. Okay, so if you can see this solution, like what they were telling means, they are given, you need to find the subarray with the largest sum. Okay, you need to find the subarray with the largest sum. If you can see here, the input is given like this. Okay, so what you need to do, the subarray in the sense consequent elements. Okay, consecutive elements. Consecutive elements, you need to find it out. So if you can see, -2 plus 1, this is one subarray. -2, 1 is subarray. -2, 1 and -3 is one subarray. -2, -1, -3, 4 is one subarray. So like that, you need to find out all the subarrays of sum of this. Okay, sum of this, consecutive in the sense side by side. Okay, subsequent. Okay, -2, 1 in the sense, what is the sum of this? Yeah, similar to subset. Similar to subset, but it should be side by side. It should be side side. A subset in the sense, what will come? You can also mention 1, 4, and -1 as also one subset. 2, -2, -3 also has one subset. Okay. -2, -3 also one subset. You can mention. Right? This is also a subset. But it should be continuous. It should be continuous. That is the thing here. It should not be a subset. The subset also should be continuous. So that means continuous. Okay. So here you need to find out the sum of this subset. Suppose this sum is what? -2, 1 is sum is 1 minus 2, which is nothing but 1, right? -1, right? -2 plus 1, which is nothing but -1. So here it is -2 plus 1, which is nothing but -1, -4, -4. Here it is -1, -4 plus 4, which is nothing but 0, which is nothing but 0. So in this, what is the maximum sum until this point? It is -1 itself, right? Then you need to check. You need to check all the things until this point. You need to check, and then you need to check -1, -3. 1, -3, -4. Like this, you should go on checking. Okay. Like what was given, -2, 1, -3, 4, -1, 2, 1, -5, 4. Okay, this is being given, right? This is being given. So what you need to do, you should check it. Okay. So then -2, -2, 1, -2, 1, -3, -2, 1, -3, -4, then -2, 1, -3, -4, -1. Like that, in that, all the sums you need to check. All the sums you need to check. And then what you need to do, again, you need to continue from next one. 1 -3, 1 -3. 1 -3 is nothing but -3 plus 1, which is nothing but 2. Right? Then 1 -3, 4. Like that, you should go on checking. So if you check like that, 4 -1, 2, 1. So 4 and -1, 2, 1 will be the greatest sum. Okay, 4 -1, which is number 3, 3 plus 2, 5, 6. This will give me 6 as the answer. If you check like that. Okay, like that, you should find out the sum. If you can see here, 5 plus 4, which is nothing but 9. Okay, 5 plus 4, which is nothing but 9. So suppose if I'm taking some max variable as this is 9, okay, and then 5 plus 4 plus -1, 9 -1, which is nothing but 8, not greater. Then 8 plus 7, 8 plus 7, which is nothing but 15. This is greater. So now it will become 15. And then 15 plus 8, 23, right? So this will become 23. Then again, what you need to do? You need to check other ones also. 4 -1. 4 -1, which is nothing but 3. 3 is not greater. Then 4, 3 plus 7, which is nothing but 10, not greater. 10 plus 8, 18. 18 is not greater. Then again, you should check the other ones. -1, 7. 7 -1, which is nothing but 6, not greater. -1, 7, 8. 6 plus 8, 13, not greater. Then 7 plus 8. 7 plus 8 is how much? 15, not greater. So the maximum sum will be 23. You need to print out the maximum sum. Are we clear? Yes. So can you can you give your solutions in the next 2 minutes? Then I will code out the solution. Whatever getting in your mind to find out this, can you put it in some English letters on your chat box so that I can code it up afterwards? I will give my solutions. That is coming to my mind. Mhm. Fine. Can we can we create different subarrays using new array, like creating new arrays and comparing their sums with previous, which has the largest will stay much. Okay. Okay. Then Mangesh, take variable maxsum and current sum, run loop from 0 to n minus 1, add element in add maximum and current sum, run loop from 0 to n minus 1, add element in current sum, and then check maximum between current sum and maximum. And also check if current sum is negative, set it to 0. Okay. Can you code that solution while I explain the solution? Mangesh, and can you tell me all your test cases are passing with this? Mangesh, while I explain the solution, try coding it and let me know if your all test cases are passing. How many test cases are passing when you submit the solution? Okay. It, that count I want. Okay, let me clear this. Mm. So as Prathamesh said, the brute force approach, what I can do, I will take a loop. I will take a loop as I explained. As I explained, I will take a loop. I will loop over the elements. I will take two loops. Okay, I will take two loops, one for iterating one for traversing, the other loop for calculating the sum. The other loop for calculating the int j is equal to 1 to n. Okay, 1 to n. And this is from I is equal to 1 to n. Okay, this is I to n. Okay, now what I'll be doing, I will calculate the sum. I will calculate the sum. Sum is equal to array of I plus array of j. Okay, sum is equal to array of I plus sum is equal to array of j. Then what I will do for every sum, I will take one variable, that is result variable. If result, if result greater than sum, if result is greater than sum, I will make that to result is equal to sum. Okay, I'll make that to result is equal to sum. I'll be taking loop. So what is the time complexity of this? What is the time complexity of this solution? So what I'm doing, I'm using a two loops, nested loops. Yes, so it will pass only some of the test cases because you are making the current sum as zero. The current sum as zero. Okay, so what is the time complexity of this? Time complexity of this? The time complexity is big of n square, right? So, and space complexity is big of 1 itself. But is it right? Can I optimize this to big of n? Is it possible? Or big of 1? Big of n only in one pass. Can I do that? Is it possible? So let me explain, let me optimize this to more. Okay. So what I'll be doing, instead of iterating over and over again, what I'll be doing, I will anyways, if there is only one element is there, if there is only one element is there, what is the sum? If there is only one element is there, what is the sum of this? It is the same element, right? It is minus 2 itself, right? So what I will do, I will make the sum as, I will make the result as minus 2 itself in the starting. Okay, minus 2 itself in the starting. If I know, in between those, which is, what is the sum? Okay, what is the sum? Can I add it up this one also to that? Yes. So if I know minus 2, like suppose I'm taking minus 2, 1. Okay, minus 2, 1 and 3. Okay, so now within these three elements, I am taking it as the sum is minus 1. The sum is 1 plus 3, which is 4. Okay, in this, what is the maximum sum? The maximum sum is 4. So anyways, I want the greater sum. I want the greater sum that is greater than 4 only. Lesser than 4, I don't want. So I will carry this forward. I will carry this 4 forward. Okay, until this point, what is the maximum sum? Until this point, what is the maximum sum? It is 4. It is 4. So now I will add this also. 4 plus 4. 4 plus 4, which is nothing but 8. Now the maximum sum until this point is 8, right? Until this point is 8. Because in this maximum sum we have no, in this sum we have calculated, this sum we have calculated, and in this sum we have calculated, which is 8. Okay, and then I will carry this forward 8 because 8 is greater than 4, right? So now the result will be 4. I will carry forward again. I will carry forward this 8 to next element. I will carry forward this 8 to next element. 8 minus 1, which is nothing but 7. Is 7 greater than is 7 greater than is 7 greater than 8? Result is 8, right? Is 7 greater than 8? No, right? Again, what I will do, but I will carry forward this 7. I will carry forward this 7. This can be positive, and if suppose it can add some 2 or 3 in the next, this will become greater, right? So I will carry forward again. I will carry forward again to next one. 7 plus 2, which is nothing but 9. Is 9 greater than 8? 9 is greater than 8? Yes. So now what I will do, I will put it as 9. And then next one. 9 plus 1, which is nothing but 10. Again, it is greater. 10 minus 5. 10 minus 5, which is nothing but 5. 10 minus 5, which is nothing but 5. Again, this is 10 minus 5, which is 5, which is not greater. So that the current sum will be 10 itself, right? And then what I will do, I will carry forward again. 5 plus 4, which is nothing but 9. It is not greater, right? So the maximum sum will be 10 in this case. Okay. So I have missed somewhere. That's fine. So what I will do, I will code it up and then I will explain once again. So I will take a for int I is equal to 0, I less than names dot length. Okay, I plus plus. Okay, then what I will do, I will declare some variables here. That is int result is equal to first element. I will take it up. Anyways, the result of the first element only I will take it up. Okay, result of I. Okay, and then what I will be doing, result of array of I, and then int sum I will be taking, that is array of I only. Okay, the first element only I'm taking it up. Okay, this one I'm taking it as array itself. Okay, and then okay, sum is equal to sum plus, I will start the loop from 1. I will start the loop from 1. So sum plus array of I. Okay, sum plus array of I. If sum greater than result. If sum greater than result, what I'll be doing, result is equal to sum. Okay, but I need to check whether it is positive or negative. If it is negative, the sum will be always the sum will be negative, right? The sum will be always negative. So again, I need to compare this sum is greater or the particular element is greater. Okay, if it is greater, then I need to I need to put it as a positive itself, right? The next number means if it is suppose until this point it is some minus 7, then minus 7 plus 2, it will become again negative only, or if it is the negative, it will be lesser only anyways. So because of that reason, I need to start the loop again. I need to start the loop again. So for that reason, what I will be doing, I will compare this sum also. Okay, I will compare this sum also. Okay, like what I'll be doing, I will write a function that is math dot max of sum plus array of I is greater or array of I is only greater. I'll check. Okay, then I will put that. So now if I run this solution, I will return that I will return RES. Okay, I will return RES and I will submit. Expected, where is that expected? Result is equal to array of 0. Okay, it is running names dot length only, right? I is equal to int I is equal to 1, array of length. Yeah, those mistakes. What is this missing? For I is equal to minus 1. Y is equal to minus 1. Why it is giving like that? I need to check max. Okay. I need to check and I need to include it also, right? Not max. Okay. Then I'm clicking on submit. Right? Accepted. Okay. I'm doing it in the only one pass. I'm doing it in only the one pass. Okay. So this is how you can do it in only the one pass. So I am checking whether it is already negative. If it is already negative, I'm putting in the next that element itself. I'm also checking the sum also. Okay. I'm already checking the sum also. Yeah. I will explain it. I need a good example. Which example I should take? 5, 4. I should get negatives so much. Okay. I will take maximum subarray sum. Good example so that I can explain. Yeah. 2, 3, minus 8, 7, minus 1, 2, 3. 2, 3, minus 8, 7, minus 1, 2, 3. Okay, see this example. So now current sum, anyways, if there is only one element is there, if only one element is there, for suppose, what is the maximum sum in this? It is minus 2 only, right? The result should be minus 2 only. Means the sum will be starting from minus 2 itself, right? So because of that reason, for result, and for sum, I'm mentioning it as the first element itself. That is 2. Okay, that is 2. Now what I'll be doing, I will add this up. I will start the loop from here. I will start the loop from here. Okay. Now the pointer will be here. I will add up this 2 plus 3, which is nothing but 5. 2 plus 3, which is nothing but 5. So I will check whether this is greater or this is greater again. I will check until this point only it is greater or adding this is greater. Okay, which is maximum. In this, I need to count out the maximum, right? Maximum, I should get the maximum sum. So adding this element is greater or adding, keeping only this is greater. So what is greater? 2 plus 3, which is nothing but 5. 5 is greater than the result. 5 is greater than the 5 is greater than the sum. So now the sum will become 5. And then I will check with the result again. 5 is greater than 2. I will add 5 here also. Okay, I will add 5 also. And then I will move to the next pointer. 5 minus, the sum is 5 minus 8. 5 minus 8, which is nothing but minus 3, right? 5 minus 8, which is nothing but minus 3. So minus 3 is greater or 5 is greater, I will check. 5, 3 is greater or 5 is greater, I will check.
It's 9 o'clock.
So minus 3 is greater or minus, so which is nothing but 5 minus 8, which is nothing but minus 3. Minus 3 is greater or minus 8 is greater, I will check. Minus 3 is only greater, right? So I will add up this. So now you see minus 3 greater than result. No, it is not greater. I will go next step. 7 minus 3 plus 7, which is nothing but 4. 4 is greater, 4 is greater or 7 is greater, I will check. 7 is greater, right? So we'll add up in the, instead of 7, I will add up the next element, that is 7. Okay. This 7 I will compare again with the 5. It is greater, right? So 7 will be added here. Okay. I will move the pointer again. I will move the pointer again. So minus 1. So minus 1. 7 minus 1, which is nothing but 6. Again, I will check 6 is greater or minus 1 is greater. 6 is only greater, right? So I will add up the 6 here. And then I will check with, I will compare with the result. No, it is not greater. And then I will move to the next. 6 plus 2, which is nothing but 8. 8 is greater or 2 is greater, I will check. 8 is only greater. So I will add up the 8 and then I will compare with the 7. Now it will become 8. Okay. Then I will go to the next 8 plus 3, which is nothing but 11. 11 is greater or 3 is greater, I will check. 11 is only greater. I will add up this and I will add up to the, this is again greater. So the maximum sum will be in this case 11. Okay, like this I am doing because why I'm checking that means, because if suppose here you see minus 3 has come. Okay, 2 plus 3 5, 5 minus 8 is nothing but minus 3 has come. Minus 3 has come. Okay, minus 3 has come, but minus 8 is too larger, right? Minus 3 has come, but minus 3, if suppose here also minus 7 is there. So here you see minus 3 minus 7, which is nothing but minus 10. Minus value anyways will become minus itself. So because of that reason, I'm adding to the positive value. I'm adding to the positive value. Okay. So like this, I can do this solution. Okay. So I will share these notes with you. The code and the notes will be shared in your LMS. So please observe it once after. Okay. I'm also sharing it in the chat. Okay. So for today, what I can do the assignment is, please note down the assignment. Please note down the assignment. Stock buy and sell. In the notes, I guess we will check that. So this one, best time to buy and sell stock, 21 problem. Please do this problem. 21, best time to buy and sell stock. Okay. And the next one, next problem also I can give, remove duplicates. Remove duplicates. Okay. Okay, I'll bring the next problem. That is remove duplicates as well. So 121 and 26 are for your assignment for today. Okay, 121 and 26 from lead code. Please complete those. Okay. So if there are any issues, let me know tomorrow. Okay. So you want the recordings, right? You can go to the YouTube and if you can search here XLR. If you can search here XLR and if you can see here, you'll be able to find in the channel. Okay, if you go to the live section here, you'll be able to see it here. Okay, day one, day two, like that, you'll be able to see the recordings here. Okay, so that's fine. Yeah, thank you so much for joining, guys. And where the notes is available, Sushmita, can you assist Sushmita, like in the LMS where it is available?
Yeah, sure, sir, definitely.
Yeah, thank you, Sushmita.
Thank you, sir. Thank you, sir. Yeah, so dear students, the materials, I mean the notes, which is already uploaded in LMS dashboard. So if it is day one and day two or materials is already uploaded, I request you to check the LMS for the notes. If you are facing some issues in LMS dashboard, you can just drop a mail to edl@xlr.com. We will check it. I'm just posting the mail ID on the chat, that is edl@xlr.com. If any query related to dashboard or something, you can kindly drop a mail. Yeah, so we will wind up for the day. Thank you all. Thank you for joining. We'll meet again by tomorrow. Thank you, everyone. Good night.